Hi, my name is Muhamad Aiman Irfan bin Asliari. This is the video presentation for Electronic Circuit Analysis and Design Projects, BEJ30403, Section 1, under Dr. Ashok Vajravelu. This is our team member of Group 11. The first one is Khuzaimah. The second one is Muhammad Adham. The third one is Muhammad Aiman Irfan bin Asliari. In this project, students are required to design an oscillator circuit to generate a sinusoidal waveform. The design should include operational amplifier and relevant component based on the type of oscillator being designed. The overall process flow for the project is oscillator specification, oscillator design, circuit simulation, and report writing and presentation. Our group are required to design a simulation that can get the frequency of oscillation of 77 kHz.
Hi, Assalamualaikum. My name is Adham bin Mokhtar, and for my metric number is DE180067. Okay, so for this part, I will present about the simulation or circuit. So basically, what we have here, our project is called peak oscillator. So the name of this project. So how do we recognize the the Colpitts oscillator? So as we know that the Colpitts oscillator, we have basic component, which is two capacitor and one inductor. So as we know here, so we have C1, okay, C2 and L1. So for this component, so we determine it as tank circuit. Okay, so for the C1, the value is 469.492 nanofarad, and capacitor 2 is 46.992 nanofarad, and for inductor is 100 microhenry. Okay, so for the resistor, okay, so for the resistor, we have R1, R2 and R3. So I will go with white color. So this is R1. No, I mean white color, a yellow color. So this is R1, R2 and R3. So basically these three resistor, which is 10 kilo, 100 kilo and 200, that we apply in our circuit. Okay, so what is this component? So basically, as we know that this is a inverting amplifier. So what is inverting amplifier here? So basically, the inverting amplifier is a type of operational amplifier. Is a circuit which produce an output of phase with respect into input by 180 degree. So as we know that we have 12 VCC at positive, and our VDD is 12 volt. Okay, so for the name of this component, this operational amplifier, called as LM746. So the connection for this will go to output, which is this device named as oscillator. The oscilloscope. So for this oscilloscope, the result, my friend will explain about it. Okay, thank you.
Hi, my name is Khuzaimah Rabiah binti Muhammad, current Nizar. My metric number is DA190155. Today I would like to explain about the theoretical calculation for our Colpitt's oscillator. We were given for the frequency value is 77 kHz. Thus, in order to find the period T, or we known as the time taken to complete one cycle, is T equal to 1 over frequency. Since the frequency is 77 kHz, then we find the T value is 12.980 microsecond. Next, in order to complete the implementation of our Colpitt's oscillator, we are using 3 resistors, which are 10 kilo ohms, 100 kilo ohms, and 200 ohms resistor. Also, we use 100 microhenry inductor, and we assume the voltage gain is 10. The frequency formula is 1 over 2 pi squared LCEQ. From this formula, we can find the CEQ. CEQ is the total value of capacitors. Since we already know that the frequency oscillation is 77 kHz, then we can find the CEQ by substitute, plug in, and solving this equation. We find that CEQ is 42.76 nanofarad. This means the total value that C1 and C2 is 42.76 nanofarad. In order to find the value of each C1 and C2, we use the formula of A. A, or known as voltage gain, is C1 over C2. Since A is 10, then C1 over C2 is 10. We get the general equation C1 is 10 C2. By solving the equation of C2, we get the value of C2 is approximately 47 nanofarad. Since C1 is equal to 10 C2, we need to substitute the value of C2 into C1. Then we get the value of C1 469.92 nanofarad, and the value of C2 is 46.992 nanofarad. Note that value of C1 is larger than value of C2. This is because C1 is equal to the output voltage, while C2 equal to the feedback voltage.
Okay, now we go to the next part, which is the simulation for this project. In this case, we use the multisim to simulate the circuit, and we key in all the value that we assume and all the value that we calculated, which is the first capacitance is 469.92 nanofarad, and the second capacitance is 46.992 nanofarad. So if we run the simulation, we'll get the actual response for this circuit, and then we need to first pause this in order to get the signal, and we get the period for this signal, which is approximately here, which is the full cycle of the signal, one full cycle of the signal, and we calculate by using the formula, the frequency formula, which is 1 over period, so 1 over 13.352 micro, and we got the answer for 74.895 kilohertz. This answer is almost the same as what we required, which was 77 kilohertz. The answer is different since this is the actual response from the calculated value of the capacitance. So that's all from us. Thank you.